So, hi everyone, welcome back. So, let's talk about consistency today. It is a broad spectrum of consistency here. Okay, so there's a diagram which is being listed here. So, yeah, I will discuss about this. What's it all about? Okay, so let's focus on consistency first. What consistency really is. So, the basic definition is either you have it or you don't. Okay, so take an example. If you go for a walk, right? If you go daily, that is consistency. You do it daily, right? So you actually do it or you don't in computer science scenarios. So if you install a software, it gets installed or it will not. And if it gets installed, it will run. So that is called consistency. Right? If a successful installation is being done, then the requirement is the software should get run. Okay, so this is called consistency. In the same way, consistency gets followed in different computer science problems. If we talk about databases, right? So there is a diagram which is listed here. So imagine you have two replica nodes, right? One is a write replica and the other one is a read replica for your database. So whenever the write operation happens for a specific value, right? If we imagine we have a write operation for x equals to a. Okay, so this A gets to write replica, then write replica syncs it to the read replica. And whenever the read operation happens, no, the latest value of A gets fetched. So this is called consistency. Your data gets in sync with the replica node 2 also when the replica 1 gets the write operation. So this is called consistency in our database operations. Okay. So we have different type of consistency in our spectrum. Okay. Some of them are listed below, which is eventual consistency, casual plus strong, right? So eventual as the weakest consistency, and as it goes to the strongest part, it's called linearizability. Okay, so where it's called the strongest consistency. So also casual plus is also called sequential consistency. Okay, so we'll just talk about them in the later video. Okay, so let's talk about eventual consistency. So our main focus on eventual consistency is on high availability, right? So there's no there's no requirement in eventual consistency or the expectations where we actually get the latest value of an event of an, or an operation. Right, if a value gets posted, like if x equals to a goes to replica, right replica, then if read operation happens, then we are not really sure if the latest value of x will get fetched. Might x will be having some other value which gets fetched while the read operations until and unless the replica 2 gets the update of replica 1 operations. Okay, so this is called eventual consistency, where we focus on high availability but not on actual good consistency. So our example is DNS system, where whenever we update our domain name system now with some different IP, when we update our domain name with some different IP now, it gets some time to sync all over, right? So this is called high availability. Okay. So if we talk about casual consistency, uh, it's all about dependent operations, right? Like some operations depend on different operations. So it's kind of a consistency, but not in ordering. Okay. So if you go for a comment system management, right? If I am the owner of that comment, right? If a particular comment which is being posted in a YouTube video or something like that, then nested comment should be appearing in my followed comment, right? So it's not happen, right? The nested comment appears first and then my comment comes. Okay. So this is not the case. So this is called casual consistency, where the operations are kind of dependent. If he goes for sequential consistency, here he preserves the ordering, right? If we talk about you go to Instagram, right? You have some your posts, right? Which are in some order on the basis of the created it whenever you upload it. So they are kind of in an order. So this is called sequential consistency, where things are in the orders. Things gets happen in orders. If an event is pushed, means the order should be preserved in sequential consistency. Okay. So this is called sequential consistency. If we go for strict consistency, then here we are ensuring the read value gets the latest write value, right? If we go an example of this again, if the write happens for the value of x, the read will get the latest value of x, means equals to a, not the older value of x. Okay, this is called strict consistency. Here, if I give one more example, updating the passwords, right? If your password is updating and it's on its way of updating database, then this will not happen that someone logins with the old password in that time. No, your transition will get blocked. Your thing, you that you are accessing that feature will get blocked because the updating operation is getting happened. Okay, so the same way transaction we use transactions in banks, right? Transaction queries where we use deadlocks to prevent, because we just use deadlock scenarios, right? So this is called strict consistency. Okay, so there always be some some performance and high availability trade-offs. So you have to give the call, right? Whether you have to focus on the strong consistency or the weakest consistency. Okay. Yeah. Thank you so much.